a 4 microcoulomb point charge and a negative 4 microcoulomb. It's kind of weird how they have like the little dash there, and then they put the dash there as a double negative. Ambiguous. That's okay, not important. Are placed as shown in the figure. What is the potential difference? Voltage A at A minus voltage B between points A and B. And they give us this. And looks like all the answers are positive. So we don't have to worry too much about the signs. Okay, so the formula we're going to use is the formula for a voltage of a point charge, which is going to be voltage of K Q over R. So I'm going to say voltage of A is going to be, I'm going to call this, actually I'm going to say voltage at A from plus 4 plus voltage at A from minus 4. I know it looks like A minus 4, but it's supposed to be, you get it, it's fine. So we're just going to combine this as K Q4 over R plus K, I would call this R4, K Q4 minus, because the negative 4, all over R4 minus. The R for 4 minus is going to be this distance right here. This is a 3, 4, 5 triangle, so it's going to be 0.5 meters. You could do 3 squared plus 4 squared, which is 9 plus 16, which is 25. 25 square rooted is 5. And that's how we're going to, but it's point, so. Similar triangles, 0.5 meters. Pythagorean theorem. And so for this then, we're going to do, I'm going to round K from 8.99 times 10 to the 9th up to 9 times 10 to the 9th. Because it's multiple choice and all we have to do is kind of get close. So it'll be 9 times 10 to the 9th times Q4, which is 4, over a distance of 3, 4/3, minus, because Q4 minus is negative, 4 over a distance of 5. And then these are, I guess that's 0.3 and 0.5, which is going to be the same, and we're going to multiply this because they're micro, 10 to the negative 6. And so now I'm going to do some simplification here. 9 times 10 to the 9th, 4/3 minus 4/5 times 10 to the negative 6. So this is times 10 to the negative 1 on the bottom. That's what the point is, which is the same as times 10 to the 1st up top. And so this is the same as 9 times 4/3 minus 4/5 times 10 to the negative 6 times 10 to the negative 1 is 10 to the negative 5th. 10 to the 9th and 10 to the negative 5th is the same as 10 to the 4th. And now we're going to combine these fractions. So we're going to go with 15 as a common denominator. So 4 times 5 is 20. 4 times 3 is 12. Times 10 to the 4th. So we have 20 minus 12, which is 8. 9 times 8 over 20 times 10 to the 4th, which is same as 4 tenths. 4 tenths, which is the same as 2/5. So 9 times 2/5 times 10 to the 4th. I know, lots of math, and I'm sorry. Which is the same as 18 over 5 times 10 to the 4th. Okay. And I don't care about what that value actually is. All right, we'll get to it. So that is the voltage at A. Voltage at B, I think it's going to be very similar. So we're going to use the same formula. We're going to end up with K times, this time it's going to be negative 4 over 0.3 plus 4 over 0.5, which is going to be very similar. So we're going to have 9 times 10 to the 9th times, let's see here, we'll have 10 to the negative 6 as well, which becomes 10 to the negative 5th, where I figured that out previously. And we have 4 over 0.5 minus 4 over 0.3. Is that the exact opposite of what we just did? I think it totally is. Which is 9 times 10 to the 4th of yes. So this is going to be, get rid of the points there. 4/5 minus 4/3 is the exact opposite of 4/3 minus 4/5. And so this is going to end up being, skip some steps here, 8, this is going to be negative 18/5 times 10 to the 4th. So this will be voltage B. This is going to be voltage A. Therefore, voltage AB is going to be, so intuitively it'd be like, oh, it's 0. But voltage AB is going to be voltage A minus voltage B here. So it's going to be 18/5 times 10 to the 4th minus negative 18/5 times 10 to the 4th. We're going to get the negatives cancel, and it's going to create a positive. And so this is going to be 36/5. 18 plus 18 is 36 over 5 times 10 to the 4th. 36/5 is going to be 7.2, maybe, times 10 to the 4th volts, which is going to be 72 kilovolts. Let's see what we got here. No, not possible. So let's see here. What did I mess up? So I'm going to check the calculator real quick. We're going to do on, clear. We're going to do 4 divided by 3 minus 4 divided by 5 times 9. That was my mistake. So times 2, 9.6. So this, I think I made a mistake here somewhere. 2/5, 18/5. Let's see what 18 divided by 5 is. 18 divided by 5, 3.6. I should have gotten 4.8. So this should actually be 9.6 times 10 to the 4th, which is the same as 96 times 10 to the 3rd volts, which is 96 kilovolts. So somewhere my math failed me, which is not surprising. And the answer is going to be 96 kilovolts. So concepts there, somewhere in the math. I would go back and find it, except probably not worth either of our time. The idea is there, and algebra is algebra. I know, disappointing, sorry. Even I fail. No one's surprised there. Part of life. All right, so that's the concept. Hope it helped. See you next time.